Have you ever wondered if robots could take over the world one day? Well, it might not be as far-fetched as it sounds.
Connection established.
Robots are becoming a significant part of our everyday lives. From autonomous cars zipping down highways to AI assistants like Siri and Alexa that organize our schedules and answer our random questions. Robotics isn't just a niche field for engineers or tech enthusiasts anymore. It's becoming a staple of our daily lives, changing the way we work, play, and interact with the world. With the increasing prevalence of these metal companions, it's more important than ever to understand what they are, how they work, and what they could mean for our future. Whether we like it or not, the age of robotics is here, and it's here to stay. So, are robots our future partners or overlords? Let's dive into the basics of robotics to find out. First off, what exactly is robotics? It's a fascinating field that sits at the intersection of several disciplines, a melting pot of engineering, computer science, and artificial intelligence. The essence of robotics is all about creating machines, or robots, that can perform tasks typically done by humans. But robotics is not just about building robots, it's about designing them, operating them, and figuring out how they can be applied to make our lives easier, safer, and more efficient. A robot could be a machine in a factory, assembling cars with precision and speed, or it could be a tiny device navigating through the human body to deliver targeted medical treatments. And the beauty of robotics is that it's a constantly evolving field. As technology advances, so does the complexity and capabilities of the robots we can create. Ultimately, the goal is to develop robots that are not only efficient but also effective, able to replace humans in performing many tasks. In essence, robotics is all about creating efficient and effective robots, which are capable of replacing humans in many tasks. Now that we know what robotics is, it's time to understand the different types of robots. Firstly, we have industrial robots. These mechanical marvels are designed to carry out repetitive tasks with precision and speed. They are the backbone of modern manufacturing, assembling our cars and packaging our goods, among other tasks. Next, there are service robots. These bots are not confined to factories, but make their way into our homes and offices. They can be anything from the robotic vacuum cleaner scooting around your living room to the robotic surgeon assisting in complex medical procedures. Lastly, we have autonomous vehicles, which are essentially robots on wheels. These self-driving machines are designed to transport people and goods, navigate traffic, and even park themselves. Each type of robot has its own set of capabilities and applications, tailored to the needs of different industries. They're not just pieces of machinery, they're essential tools that help make our lives easier and more efficient. From manufacturing to healthcare, robots are revolutionizing numerous industries. We've talked about what robots are and the different types, but how do these amazing machines work? Well, the answer to that question is fascinating, and it's not as complex as you might think. Robots work by following a three-step process: receiving instructions, processing these instructions, and executing the commands. Let's begin with receiving instructions. Robots are usually programmed by humans to perform specific tasks. These tasks could be anything from assembling a car to exploring the surface of Mars. The instructions are given to the robot through a control system, which could be a computer or a remote control. Once the robot has received its instructions, it moves on to the second step, processing. This is where the robot's brain, or its central processing unit, comes into play. This CPU interprets the instructions it has received. It's like a translator, turning the language of the instructions into a language the robot can understand. The final step is execution. After the CPU has processed the instructions, it sends commands to the robot's muscles, or actuators. These actuators can be motors that control the robot's movements, or they can be other devices that allow the robot to interact with its environment. For instance, a robot might have an actuator that allows it to grasp objects, or one that allows it to drill into a surface. And let's not forget about sensors. These are the robot's sensors, allowing it to interact with its environment. They collect data about the world around the robot, which the CPU can use to adjust the robot's actions. For example, a robot might have a sensor that detects obstacles, allowing it to navigate around them. So, in essence, a robot is a system of parts working together. It receives instructions from a human or a control system, processes these instructions with its CPU, and then uses its actuators to carry out these instructions. And all the while, its sensors are collecting data about the world around it, allowing it to adjust its actions as needed. So, in simple terms, robots are smart machines that follow instructions to perform tasks. We've come a long way in robotics, but what does the future hold? As we gaze into the crystal ball of technology, we see the future of robotics intertwined with advancements in artificial intelligence, machine learning, and automation. These technologies are the building blocks of the next generation of robotics, shaping a future where robots are more integrated into our everyday lives than ever before. Imagine a world where robots don't just follow instructions, but can learn, adapt, and make decisions on their own. That's the power of machine learning. By processing vast amounts of data, robots can learn to recognize patterns, make predictions, and improve their performance over time. They can learn from their mistakes, adapt to new situations, and even anticipate our needs. Artificial intelligence takes this one step further. It's not just about learning, it's about understanding. AI enables robots to comprehend complex concepts, understand human language, and interact with us in more meaningful ways. They can become our companions, our caretakers, and perhaps even our colleagues. Automation, on the other hand, is about efficiency and precision. Robots can perform repetitive tasks faster and more accurately than humans, freeing us to focus on more complex and creative tasks. From assembling cars to picking fruits, automation is revolutionizing industries across the globe. But with these advancements come challenges. How do we ensure that robots are safe and reliable? How do we protect jobs in an increasingly automated world? And perhaps most importantly, how do we ensure that the benefits of robotics are shared equitably across society? These are complex questions that require thoughtful answers. But one thing is clear. The future of robotics is not a distant dream, but a reality that is unfolding before our eyes. And as we stand on the brink of this new era, it's crucial that we understand these technologies, their potential, and their impact. Robots are here to stay, and understanding them is our key to a future where humans and robots coexist.